Hello and welcome to today's webinar. During this webinar, Henry Jukes will discuss the impact of architectural changes on engineering metrics and how to measure these impacts. So a bit about your presenter today. Henry is a staff software engineer at Split Software, having developed data pipelines and analysis software for financial services and relation management industries. Henry brought his expertise to the development of Split's feature experimentation platform. Prior to Split, Henry held software engineering positions at RelateIQ and FactSet, leading engineering teams and driving technical architecture. Henry holds a Bachelor's of Science in Computer Science from Rensselaer and a certificate in A/B testing from the Data Institute at USF. Just briefly about Split. Split provides a unified solution for feature flagging and experimentation, letting you release software rapidly and safely while measuring the business outcomes you deliver through software. You can learn more about Split by visiting split.io. So before we jump in, Henry, I was curious to know why you chose this particular topic for today's webinar.
Certainly. Good morning, Jason. For this particular webinar, I've worked in engineering teams and driven architecture for the better part of the past decade, and throughout that process, have been using the same set of tools and techniques for being able to evaluate whether a rollout or a new change was successful. And as my career's evolved and I've worked with more innovative teams, we've learned a lot of techniques throughout the process that have been able to deliver a lot more value and a lot more clarity to those rollouts. So I really wanted to share those insights and learnings today and be able to focus in on how you can improve the process of any architectural change that you might want to make, regardless of where that lives within your product.
Great. No, appreciate the background. And with that, I'm going to turn it over to you.
Great. So in terms of how I'm going to approach this webinar, I'll start off by just kind of talking about the types of architectural changes or what it means to make an architectural change. Then I'll be focusing on engineering metrics, how we track them today, how we hope to track them going forward, and really what are the most valuable metrics to be able to monitor as you make these changes. And then finally, I want to review two examples of where being able to use this more innovative approach to tracking architectural changes can deliver a lot of value and has made a huge difference for my team here at Split Software. With regards to architectural changes, a lot of people have a lot of different views on what architecture represents. For me, I think that is really any part of your system that isn't necessarily that powers the core product features and the core value proposition, but may not necessarily represent a true feature in and of itself. This does start off with the feature development and all of the technology that supports that. But it goes into things like code refactors, where you're really looking to make no meaningful change to your platform besides maybe increased readability or performance. And then also it goes to much broader initiatives like a platform migration or database migration, where you're transitioning from one style of architecture to another and modifying a very large component of the underlying system, hopefully with no visibility to your customers. Within feature development, that does certainly, one needs to consider the architecture that's involved in introducing new systems, whether those be databases or new services to the platform. It might be expanding the use of existing code paths, adding functionality or additional database calls, or maybe more complex algorithms to the way that you're serving your existing features. You can also be adding, those changes might add a lot of complexity, and so therefore need to be reviewed in depth from an architectural perspective in a way that more traditional or smaller feature release may not require that insight. And also things like bug fixes, whether those be performance-related bug fixes or user-related bug fixes. Those are small changes that can sometimes have really unexpected results. When we talk about code refactors, that is, a lot of people think of just cleaning out unused code, being able to go through your code base and practice good hygiene. You can be simplifying something for readability. You may see a problem in the existing way or struggle to understand it, and breaking something down into a variety of methods is really useful. But also, one of the largest refactors that we're seeing a lot more these days is when people are taking a large service or a monolith and breaking it into a smaller service-oriented architecture. That requires listing large quantities of code inside of your system and transitioning that into completely new models. And you want to be able to make that transition in as safe a way as possible. And then that leads me into platform migrations. Whether that migration is to scale your existing technology or to introduce new technologies, you need to be able to track every step of that process, make sure that you're doing it in a manner that is safe and is able to avoid adding problems or introducing larger issues than the migration is intended to resolve. And it's also necessary to keep in mind as you go through the process of retiring an existing system. Even once you've fully migrated your architecture over to some new platform, you need to safely and efficiently retire that old code in a way that won't affect your customers. So in order to do these transitions, it's really important that you're tracking the right metrics, and ideally that you're tracking those metrics in the right way. Everyone's familiar with your classic dashboard. Here's a screenshot from a dashboarding platform known as Datadog. And you probably have this if you're in an engineering department or work with engineering departments. You've seen these on TVs in pretty much every engineering office around the world. And what these dashboards represent can be everything from database performance to your CDN to components of your API layer or incidents that are happening across your platform. So really, these dashboards are really oriented to be a great heads-up view of everything that's going on in your system, but they have a few drawbacks. First, they do show that overall state for a given metric or for a set of metrics, and are limited to the scope of your entire platform. They're temporal, so anything that you're identifying is something that shows those changes over time, or maybe you have a known range that you say this would be anomalous behavior, whether that be automated detection or something that you manually set. And again, it gives you that, it's really designed to inspire action elsewhere. You see some behavior that you're not expecting or that may be problematic, and you use that information to drive, to reflect on what you know to be other changes that are happening within the platform and to drive behavior along those lines. While this is an essential part of the engineering toolkit, and something that I think will continue to be a part of what we do, I believe that it lacks the depth and the visibility and clarity that you really need to be able to make decisions as fast and efficiently as possible. The ideal kind of modern engineering dashboard is able to show context. It's able to show the states of these metrics as it is influenced by the actions of engineering, by code changes that are happening, by code deploys that are happening, or by the rollout of a feature to more and more users. Ideally, they're comparative. It's able to use that context of what code changes are happening and attribute changes to metrics back to their root causes. This makes it really efficient to be able to identify problems. It requires that massive amount of internal learnings and corporate knowledge that is typically required to be able to efficiently debug issues when you see a metric move the wrong way. And in an ideal world, these dashboards are more actionable. They would be in a position to provide the tools to act, whether that be to dive further into the metric and really understand what's going on, or even to be able to fix those problems at the source. But so the biggest question would then be, like, how does that work? How do we provide that context? because it's really at that top level of being able to identify where in the product are we seeing issues, what is the root cause of the behavior that we're seeing, that is critical to being able to identify the process by which we can fix that. So we have found through work over a variety of companies and through working with a lot of companies with our feature flagging platform that feature flagging tool is core to the ability to gain that context and really understand your metrics in a very valuable way. For those that aren't familiar with feature flags, it is a simple way to implement your code and instrument that code to be able to determine and control who sees what feature and when they see that. Now, when I say feature, that could be your traditional, new UI change or additional functionality, but that can also be any change to the underlying code. So something as simple as, will this bug fix that I've pushed run, follow that fixed code path or the old code path, to do I utilize one database or another database in my read procedure. By having that granularity, it gives you the ability to slowly ramp up, first testing a feature out just for your internal team, and then slowly spread that across your customer base. It also gives you the ability to safely ramp something down, where if you are in the process of making an architectural change and you discover an issue, you are in a place to be able to very safely and efficiently disable that, address the problems without exposing any additional customers to the issue, and then work through that process once again. Finally, when it comes to metrics, the core value of this feature flagging platform is to then be able to attribute any behavior of your customer base back to the features that they were exposed to at that time. With that information, you're able to find very powerful insights and be able to see the effects of a metric, even when the population being affected is very, very small. One of the biggest difficulties with a classic dashboard is that you're looking at the behavior across all of your customer base. And so if you roll out a feature for 1% of your population, oftentimes any anomalous behavior that's occurring for that part of the population gets lost in the noise of that metric and would never show up on those classic dashboards. By being able to take in the context of feature flags, you're in a position to be able to understand how that behavior is really more broadly affecting the customers at hand, and be able to identify and compare how the behavior of a metric is in one set of users with the feature or code path turned on, and for the customers with that code path disabled. Now, traditionally, feature flags are used at an account or user-based level. And this is a very common practice, whether that be for experimentation or for simply being able to coordinate which of your customers are going to be observing this new feature and be able to manage with your customer support team any feedback that comes as a result. However, as you deal with architectural changes or really any engineering change, sometimes that level of granularity is quite small. And so to be able to see meaningful results, it's actually very helpful to be able to look at the effects of a single session or single request against your server and get that deep granularity to be able to see how one code path is operating versus another. When it comes to making a request from your underlying database, it really doesn't matter being able to compare the performance of one architecture versus another. Doesn't care as much about the specific user who made the request as it does the ability to get that meaningful comparison between each request that happens. This gives you a much greater sample set in a much faster way and allows you to really separate out and dilute the impact of super users that might have very large discrepancies in the metrics that they're generating. Now, as we're working in this new format, you then need to think of your engineering metrics in terms of how well they can be contextualized. A lot of the traditional metrics that people look at have to do with the entire health of the system. And while that is a necessary component to being able to identify more systemic issues in whether that be your code or the implementation of your infrastructure, being able to get the additional context and choose good metrics that can be contextualized gives you a great amount of value. The first and foremost, we break things down into success metrics and then guardrail metrics. For any change, if you're at all familiar with product-based experimentation, typically you look at you choose a set of key metrics that are going to be what effectively your hypothesis was for why you created the product feature or why you made the change. Now, when you're evaluating those changes from an engineering point of view, you aren't caring so much about things like engagement or the power, or how that drives sales, but you are interested in some core metrics that deal with how that particular part of your infrastructure is being used. So first and foremost, having some monitor of usage metrics, being able to look at the number of requests that are coming in, looking at the activation rates of a particular code path gives you a lot of depth and insight into what is happening within your system. It is able to prove that this code path is working, that you're getting the functionality that you're expecting it to have, and to be able to give you a rough base of comparison so that you can ensure that the behavior that you were expecting to drive is truly happening, and it's a really good canary in the coal mine for other issues that might be happening in your code paths. There are a specific set of performance metrics that may be the core of why you made a change. You may be interested in being able to say, oh, I drove this new database change, or I updated the algorithm with the intention of being able to make this code path faster, or to be able to get a greater throughput of my requests. Being able to evaluate those performance metrics, in particular those around latency, gives you some really core success metrics to prove that this change that you made had its intended behavior. But for a lot of the changes that one might be making, you aren't actually intending to drive metrics in one way or another. And so being in a position to track a variety of metrics and ensure that they're remaining stable or that they aren't degrading in a meaningful fashion gives you that peace of mind to know that there aren't outlying issues that you have to worry about. And so being able to look at a broad swath of related metrics is really powerful, especially when you're able to take into account the behavior of those metrics historically and the statistical significance when compared against the people that aren't in that new code path. Talking more about those guardrail metrics, once again, latency is kind of our core powerful performance metric that we're interested in. So it's very easy for us to look, whether that be for the whole round trip of a particular code path, whether that be for accessing of particular services or databases that might be in your code stack, or for simply the performance or the complexity of particular algorithms. It gives you some strong signals for whether there's either any degradation to the behavior or if you're getting the types of results that you're expecting. Another really great example is being able to look at errors and exception rate. By being able to associate exceptions that occur with the user that was making the request or the request itself. It gives you that depth of analysis to be able to see that there's a major impact that's happening. And that puts you in a position to identify bugs very early in the process without you having to expose many users to that. One thing that's actually really difficult to track are things like load, because typically the load on a database or a particular system is going to be highly dependent on the volume of requests that it is receiving. And so as a result, being able to do a comparative check between requests, there would be a lot of interference between the two data sets. And so it's actually really valuable to instead either find a way to isolate out the load between the two systems, and then you can average that out between all requests. So in a place where you're moving from one database platform to another, assuming that those databases are only used by this particular part of your code, then you can do a comparative analysis to see if there was a alleviation of some of these key metrics. But beyond that, we find that latency is a much more effective signal for being able to determine what's going on. Finally, I want to go into two examples of how I've leveraged these techniques to both identify issues as they're arising, but also to then make sure that we're able to manage these architectural changes in a way that's going to be highly effective and gives you that safety net that you need. So one of the types of architectural changes that I talked about at the beginning is this notion of a code refactor. So for us, we were making a very clean change. We were removing a lot of code, cleaning up what we were doing, and it had no intention to make a meaningful modification to the behavior of our code base. The expectation was that the new code path would have effectively the same set of logic, but would be in a position to be able to run that in a way that we can support much more easily over time. However, when we began the process of rolling this new code base out, we were looking at one of our guardrail metrics, which was the general page load time across our entire product, and we saw a meaningful change to that metric. Now, obviously, we did not have enough data for statistical significance. This was only a few hours into turning on that feature. We'd only turned it on for a very small subset of our customer base. So at this time, it was turned on for 5% of customers. But we were familiar with the behavior of that metric historically, and page load time is something that usually is relatively difficult for us to change at this scale. And so that was a very early indicator that there might be something going on there. Now, looking at our big board metric, our average page load response time was completely level. So we began the rollout around midday on Wednesday. And as you can see from this chart, there was next to no change in the behavior and nothing that would indicate to us that there would be any concerns in what we were tracking. But we do know from prior experiments that we're used to this being a metric that is either statistically inconclusive or changes by a very small amount. And so that was a signal for us to go and dive into the code base before we were chose to ramp up that metric, that experiment any further, and make that change a more broad refactor for the system. As we dove into the system, one of our core permissioning piece of permissioning infrastructure, the ACL controller, we noticed in the new code lacked this annotation for using the cached version of the data base. Now, without going into too much detail, by having a cache on the permissions infrastructure, this is something that this permissions infrastructure is being called often multiple times per request in order to make sure that all of the authentication for every part of the functionality is moving in a way that is permitted. Without that cache in place, it meant that we went from potentially 0 to 1 database hits per call to now potentially half a dozen or more. And it was those additional database hits across the entire system that were driving up our page load times in such a dramatic fashion. And so by being able to not only look at our metrics in a fashion that gives us that is associated with the feature change that we're making, but also by being able to go in and break out the data between the people receiving the treatment and those not receiving the treatment, we were able to, even at a very low sample set, detect a bug that otherwise would not have been detectable at all within the data of classical dashboarding, and that we typically would have had to roll out to at least 30, 50, maybe even 75% of our customer base before we saw meaningful changes. And as we've worked with a lot of customers, the impact of an increased page load time for a website can have a dramatic downstream effects on retention of those users and the rate and the amount of time that they spend on your site. And I want to talk about kind of the big beast of architectural changes, which is a platform migration. Now, data migrations are hard. Typically, they require a lot of steps in the process, and there's a huge amount of risk involved. Now, you might be making a migration because there might be more efficient storage formats. You might be trying to do so to add new features into your system, or to transition to an alternative technology that provides greater scale or better systems of management. Sometimes it's even something as simple as moving to a new provider, that moving either to consolidate all of your providers under a single cloud platform, or to move to an independent provider that might offer greater support or greater functionality. It would, there's a lot of reasons why you might take an existing collection or an existing data set and move them to a new solution. Now, in the traditional model, there's a lot of things that go into that process. First, you have to go in and change your object model to be able to support the new database layer. You have to create and update the access layer in order to integrate with that new system. You need to go through, build that code up into a deployable executable. You need to stop the world, stop everything that is being written to the existing database, all of the keys and services that were performing that writing. You have to migrate any old data that was happening, that lived in the old system, over to the new system. You deploy that code out, that change code out once that migration has happened, and then you start things back up again and just hope that everything's working. There's a ton of risk involved, and oftentimes this would mean hours of downtime, people working overnight or on the weekends in order to get this deployed. And in the case where there's an issue, you would wind up in a position where you might have potentially lost data or a really complex migration to sync data from one system back to the other before trying this whole process over again. In the case there's a problem, obviously you have the downtime. You have to go in and revert all of that code. You have to find any data that you've missed and manage corruption. And then again, you have to follow that checklist again for migration. Now, what I've found to be the strongest and most effective way to do this is something known as a dual write and dark read system. So initially on the writing process, this is an example when we migrated from Elastic Cloud to AWS. And so in the process of performing that migration, you would have the individual code paths for which system you're doing the writing to, and you would also support a code path where you're able to write to both systems. What that allows you to do is start the writing before you perform any data migration, so you ensure that all data is there and valid and available to you. You then go through the process of migrating that data while new data is streaming in with zero downtime for your customers. You're also in a position to migrate either a single set of requests, a single user, or a single account over to the new system and be able to ensure that everything's working perfectly for them. You've worked through every step of that migration process at the small scale, when those data migrations might take minutes rather than hours or days to run. And it puts you in a position to get a really valuable proof that you're able to perform this safely. If there is an issue, you can easily just disable the dual writes, go back to the original solution, and work on migrating going again once you've resolved that and pushed any necessary code changes. On the other side of things, there's then the read path. And so you follow a very similar procedure for any reads that you'd be making against this collection, where you're able to transition from one database to another. And instead of performing dual inserts, you'd write what is known as a dark read, where you fetch the result from both systems at the same time, compare the result from the new system against the old one, validate that it is the same, and that or that any changes between the two are as expected. And then you can, once that is completed, then you can log any issues that arise so that you can track down with live production data any issues that you may have missed during testing. And then once you are positive that there are no data issues with your existing customers, you can slowly migrate them off of the old system fully onto the new system, and then later on clean up the code and retire all of these writes to the old system, and then the reads from that system. This also gives you the ability to safely disable things, and also from the perspective, doing those reads against two databases can potentially be quite expensive. And so to avoid that additional work, you can perform those reads at a small fraction of percent of the requests that you're performing. And so rather than looking at every request for a particular user or account or even session, what you can do is look at only a small fraction of the total request volume, and that will give you a strong indicator of whether you're having a successful rollout and be able to identify any issues without impacting the performance for the majority of your customers. So by following this phased rollout method, it gives you the ability to do these targeted transitions to make sure that first, for test organization, for beta customers, maybe for the customers that are the least risk averse and willing to work with you in the case where any issues occur. It allows you to focus that and make those migrations at a small scale and make sure that everything works. Those partial migrations save you a lot of time and a lot of headache in the case that there are any issues. You then use that dual writes dark reads model to be able to make sure that you're getting a very efficient and successful result, and that every step of the process you're able to see valuable data. And speaking of that data, when we perform this migration, really this is a case where we're just really leveraging those guardrail metrics. So what we're looking for is everything from tracking those latencies. We were actually fortunate enough in this case to see that there was a meaningful improvement in the aggregation latency, that read latency that we were seeing. And we were also then able to track the exception count as one of these guardrails, just to make sure that we weren't seeing any errors or problems across either one of our systems. And this gave us a really strong insight to make sure that everything was working exactly as expected. And if we saw an uptick on one service or the other, we could go in and address those problems as soon as they happen and avoid any, and be able to quickly turn off this functionality. In this webinar, we've covered a lot of ground, kind of talking about the types of architectural changes that you might be making and why they're important to track. We've talked about how you can take a new approach to tracking those architectural changes by looking at your metrics in context and being able to, even at low sample sizes, understand the effect of those changes and be able to act early when something's going sideways. And then finally, we've gone over 2 examples of issues that of how you can perform efficient architectural changes and how you can use these metric systems to make sure that you're getting the greatest value and that you're performing those changes to the greatest level of safety. Thank you very much, and we're open to any questions that you might have.
Great, thanks, Henry. Yeah, we did have a few questions come in. The first one is, you mentioned that in modern dashboards, you can take an action when something needs fixing. Do you set safety parameters for all of your metrics or just core metrics?
So oftentimes you're looking for safety parameters across anything that's going to have a meaningful impact on the rest of your system. And so in some cases, those core metrics, the things that you're expecting to drive, might actually be the things that are the slowest to change. And so there's a lot of leading indicators that you can get from small things like query latency or error rates that you might not be seeing from more holistic measures. And so being in a position to set those thresholds for your global dashboarding is really powerful, but you need to take into account the fact that they will have a hard time detecting any issues when you're doing a small scale rollout.
Great, yep, that makes sense. Another question is here is, we don't have a lot of customers, so do I need to roll out features to a larger number of my customers to understand the impact I want to test?
Yeah, so there's, as I covered, there's kind of a few different ways where this analysis is going to be really valuable to you. So first and foremost is that even without statistical significance, you're able to get a lot of insight from seeing the direction in which these metrics are moving. And by being able to isolate down these metrics to just those people that were exposed to one treatment versus the other. Then, early on in the process, when you don't have statistical significance, it's you don't want to be making necessarily business decisions, but they can be really great canaries for you to indicate that there may be an issue that you want to look into before you start ramping this up to a larger audience. Similarly, especially when working with these engineering and architectural changes, it is oftentimes not necessary for you to be doing this rollout necessarily on an organization or a user basis. And you can leverage something like requests or sessions to get a much higher volume of data to gain statistical significance and a comparative basis without necessarily having to work with, be constricted by your low sample size. Were there any other questions?
Yep, sorry, just reading this one through. It says, for the guardrail metrics you talked about, if a bug pops up, can you automate rolling back a feature, or do you monitor the dashboard and manually roll it back if needed?
Yeah, so it'd be really powerful in kind of both cases, being able to monitor and have that action ability available to you right on that dashboard. Now, within the Split platform, we've taken the procedure of killing a feature or rolling something down a single click away, and being in a position where you can understand and monitor your metrics to be able to know for this particular feature change what is within or outside of bounds. Over time, it's certainly something that we'd love to find ways to both automate, but there's an element of understanding a particular customer's data that that we want to be able to empower people to set those thresholds for themselves, and then describe the kinds of actions that are meaningful to them to be able to understand if that's an action they want to take.
Great. So I guess if something does show a red flag, are you guys alerted, or is the team alerted so you can take an action quickly?
Yeah, so that's being able to wire up those alerts and know about those actions that we can take is a critical part of our workflow.
Mm-hmm. Great. Okay. Here's another one. It says, do you let customers know when they're going to be part of an experiment?
So it really depends on the type of experiment that's being run. So when you're working with something that is going to be, you know, a lot of these types of architectural changes are something that maybe a request from a customer or a new feature that's been asked for, and then we definitely work with our existing data and work with our customers to identify people that would get the greatest value and be able to provide the strongest feedback for whether this is an effective solution for them. We find that collaborative method is really great for getting that initial feedback and that qualitative dimension that is able to inform the rest of our qualitative approach. But then for other sets of changes, whether those be bug fixes or really something that we want to perform an effective experiment on when it's a user experience change, that's where it's really valuable to typically turn on that feature or functionality for a randomized subset of your user base. And then, you know, you may be able to provide some sort of messaging if it's a new feature to say, hey, here's a new feature, here's how it works, just to onboard them onto that functionality. But you may not describe to them, here are 2 different options, because that can bias the results of that experiment. There's a strong element, especially for very large companies or people working with more sensitive data or more sensitive customer types, that you want to keep in mind a really good element of the ethics of the experimentation that you're going to be performing with your customers. But as long as you're focusing on simple product changes that you aren't looking to drive, you know, user behavior outside of the product in a meaningful or negative way, then it's recommended that for those types of user-facing changes to be able to get a randomized, controlled data set that wouldn't be biased by knowledge of the experiment that's running.
Yep, that makes sense. I think we have time for one more question. Let's see. So is there a typical number of features you feel comfortable rolling out with any deployment?
Yeah, when it comes to making deployments happen, so the great benefit of feature flagging is that you're able to completely decouple the features that are rolling out with a given deployment and when you're exposing customers to those features. So it gives you the ability to incrementally work on or develop those features, test them internally, even in a production environment before you start to expose customers to it. In terms of the number of parallel experiments or parallel feature rollouts that you're running, really depends on the scale and complexity of your team rather than necessarily the complexity of your user base. Because if you look at some of these largest largest experimentation platforms, they might have tens of thousands of varieties of their website, tens of thousands of feature releases happening simultaneously. Typically for smaller scale customers, the biggest blocker there is not so much the randomization or the rollout, because a well-designed experimentation platform is able to distribute the effects of any given experiment efficiently and cleanly between across any other experiments that are running or other feature rollouts that are occurring, and similarly can be in a position to identify so-called bad seeds, bad rollouts that would put you in a position where where it would be influenced by the running experiments. But then given that what you want to be able to manage is the complexity of that code and architecture, because every feature that's being developed, every feature that's being released introduces an element of both cognitive and technical debt of being able to make sure that you're effectively tracking that, you're making the correct rollout decisions, and that you're in a position to clean up those branching code paths as they get released.
Great. Well, we are just about at time. So, Henry, I wanted to thank you very much for today's presentation, as well as thanking all the attendees. I want to let you know that all the slides that Henry presented will be sent out to all attendees, and they will also be, the full recording will also be available on the Split website. So, again, thank you very much, Henry, and thank you for all the attendees.
Thank you.